Hi students, let me discuss about last video. We done the program status word, that is a flag content present in 8051. In this video we are going to learn about memory register present in 8051. The main important is internal memory, that is 128 bytes of RAM as well as 4K of ROM. How the structure of the RAM and the ROM, we'll see that. So comes to the 128 bytes of RAM, that is the internal RAM. As we know that it is all are assigned as addressable, that is from 00 to 7FH, that is totally it is 128 bytes of RAM in the 8051. That will be divided into three groups. One is working register, bit addressable register, and general purpose register. That's also called as scratch pad area. So there we can use to store our data and retrieve the data from that area. As we know that there is a the total of 32 bytes of location from 00 to 1F are the register bank. So in that we have the stack also. A total 16 bytes from location 20 to 2F are bit addressable. There we have read and write the memory by bit with individual address. And third we have the total 80 bytes from location 30 to 7F are used to read and write the storage called scratch pad or general purpose register. Comes to the location. So as we know that it is 0 to 7, it is register bank. So the starting address 7, the next address is 08. So always the stack pointer holds the top of the stack, that is minus SOP, stack top of the stack, that is TOS. So when you made a reset, that's what stack holds the address is 07. When it comes to the stack operation, then we can understand that how the stack works. So we should remember that stack starting address is 08 to 0F. This is the range. Next, register bank 2, 10 to 17, that is 8-bit. Register bank 3, 18 to 1F. So all these register banks, it consists of R02, R7. Each have the R0, R1, R2, like R6 and R7. So each have the bit addressable one, R02, R7. So this is the area. We have the registers from R02, R7. So these are also a bit addressable area. We can address this bit. We'll come to the later how we can address to this. 20, this is 20, 21, 22, like that until 27. So this data I need to take from bit by bit. Will come later. What are the bit addressable area? How do you access that bit through the instruction? And this is the area, the scratch pad area, or also we call it as general purpose register. So here we can use to store our data into this and retrieve data by programming. So 8051 register bank structure: bank 0, bank 1, bank 2 and bank 3. So bank 0, as I told that it is consists of the R0 to R7. Similarly bank 1, R0 to R7. Bank 2 and bank 3. So we should remember that each bank have an 8-bit register, and also the starting address is 00207 of the bank 0. Similarly bank 1, this is 08, is also called as a stack. Bank 1, 082 0F, and 102 bank 2, it is plus 8, it is 17. So the next 18 from this plus 8, it is 1F. So remember 002 1F, we have the bank registers. Okay, default it is always taken the bank 0 register. So that's what in the PSW we have the registers. Select RS0 and RS1. It tells that whenever it is 00, it is selected the bank 0. So these register we can use to working out our program or store the data temporarily once it is in default 00. So this is clearly I mentioned here, register bank, that is an address 00207, register bank 1, that is a stack 082 0F. So if you want to address the register, so 00, it points us to the bank 0 or not. Okay, likewise these register I can refer with the name as well as this address. Similarly we have the register 2 10 address with the R0 17 and register bank 3 18 to 1F. These are all present in the RAM area. So totally this is our programming model. Sometimes they are asking to explain the programming model of 8051. So then we need to write the RAM content and whatever the special function register present along with the ports and program counter, all the one. So if we remembered all these things, so programming is very easy. So as we repeating once again, we have the accumulator, we have B register, totally we call it as a math registers, works with multiplication and division. So those we are using, that's what we called as a math register. So instruction pointer, or interrupt pointer, interrupt enable, so that is interrupt register, timer register, T mode and Tcon register, and we have the timer registers TH0, TL0, that is T0, TH1 and TL1, that is T1. We have the two timers. And serial data register, serial communication, SCON. We store the bus, buffering the data, SBUF register we are using. So then we have the parallel communication, PCON, configuring, we are using that. And we learned the PSW also, program status word, that is what we call as a flag. And the stack pointer, that is started with the bang 2. This is what the stack pointer area. So pointing this area through the register is SP. So this is your stack pointer register. And external memory to access, we have the data pointer register, that is what we call it as DPTR. So that is splitted in DPH higher bit, lower bit is DPL, data pointer low and data pointer high. And we have the program counter. This will be fetch the address of the instruction and decide which instruction going to be fetched. This is the process of program counter. So this is 16-bit and this is also 16-bit. So probably they are going to asking in the MCQ question, how many 16-bit registers are present in 8051? There are two 16-bit registers. One we have the program counter, another one we have the data pointer register. Next we have all the ports, port 0, port 1, port 2, port 3. So they're all we can use as IO lanes. These are all 8-bit registers. So next we have the internal ROM area, that is 4 kilobytes internal ROM, that is the starting address is 002 FFFF. So this we can store by the program. So normally this is we call it as program memory, and your RAM we call it as a data memory. This is what program or code memory. Okay. So this is briefly we given the address of all the registers. Now we'll see the operation of stack. Remember, stack is a section of RAM, that is the area we can remember that it is starting area is 08H2 plus 8, that is 0F. This is your stack. It allocated the memory like this. So the previous data allocation is 07. The register used to access the stack is called the stack pointer register, that is what we called as SP. The stack pointer is the 8051. In the 8051 is only 8-bit wide, which means that it can take the value from 002 FF, so that the size of the stack pointer, it is 8-bit. So 8-bit in the sense we can have the data of stack pointer, it is 002 FF. This data it can taken. When the 8051 is powered up, so the stack pointer pointed to the new top of the stack, that is 07H. The value it is 07H. So RAM location 08 is the first location begin used to stack by the 8051. So this is after the 7th, the next location is 08. So this is the beginning of your RAM. So here we'll see that how the RAM will work. We are using the two instruction. One we have the push instruction and another one we have the pop instruction. We'll see the push and pop how this will be works. So consider this is your stack area. The new top of the stack, that is TOS, always pointed to the 07H, the previous data address, and the next address is 08. So new top of the stack, always it's pointed to the negative number, the next number. Once you going to push into this, so you are going to push the data into this, the first operation, so this is pointed to the register as SP, stack pointer. So then stack, it is started, the address is 08. So then what we'll do, the first operation is stack pointer, it is incremented by 1 first. Now the point is to SP here. Now the data, second one is the data is putting into the stack pointer. So let me put the data as let's say something AXV, A we written, the content of A is pushed onto this, let's say 10 I pushed the data here, and similarly I written one more push, so here again 11, let's say push 12. So these are the data it is pushing into the stack, and now the top of the stack pointed to the where data has pushed. Similarly, we'll work on the pop instruction. So now the top of the stack is this. Remember the stack, it is operated in last in first out. Whichever it is last you push the data into the stack, that is come first. So now this is the last point, it is coming out of the first data here. How we'll take this first, the pop. So now here the first operation of this pop instruction is first the data from the stack, it is taken into, let's say pop A. So that data it is coming into the accumulator from the stack pointer. Whatever the data from the stack pointer, now the 12 it is coming into the accumulator. So next we need to reduce this stack pointer to the next the data. So that is SP. Now the stack pointer it is decremented by 1. So how many pop you written? So that many the data has to be retrieved from the stack. When the last is, we need to check that stack pointer, it is new top of the stack, what you are defined as the address is 07. So then it is empty in the stack, that we can say that is empty. Next, the size is 0f. When the stack is full, when the stack is full in the sense we push the data until here, whenever SP is incremented, SP become 0fh, then we can say that it is stack is full. So these are the conditions we need to check every time by using the push and pop instruction. We need to check the stack is full. If it is full, we can't push the data into the stack. The next, we need to every time check before the stack pointer it is empty. Then empty in the sense we can't retrieve the data from the stack. So this is how the stack will be working in 8051. So just I'm briefing that the storing the CPU register in the stack is called push. SP is pointed to the last used location of the stack. As we push the data onto the stack, SP is incremented by 1. This is different from many microprocessor. Loading the content of the stack back into the CPU register is called pop instruction. With every pop, the top byte of the stack is copied into the register specified by the instruction, that is pop A, that is a what register content. We can take the data from the stack pointer. Okay, then stack pointer is decremented by 1. So this is the operation of stack pointer. Remember, this is very important. They're going to asking the question like explain the stack operation in 8051. Next we'll come to the bit addressable and byte addressable. The area we came to know that the bit addressable location starting from the address is F0 to 2F. So F20, it means that started address is 0000 first location and 07. So this is I can address by bit. I can make this bit as a data as set or reset. It means that I can make that bit as 1 or 0 with respect to that address as 20. Let's have some example to make out to understand about the bit addressable area. For that we have some of the instruction. Let me see that I can use the set bit instruction. This is the bit, whichever the bit you are specifying, that will be making as 1. Clear bit, clear that particular bit. So next we have the complement bit, CPL. We should remember all this instruction. Set bit, clear bit, complement. And we have some of the conditional jump instruction. So jump to the target, JB stands for jump branch, to where the bit, if the bit is equal to 1, then we jump to that particular target. Here also we can specify which bit it is 1 or not. Jump no branch, so the bit will not equal to 1, then jump to that particular location. Or we can say that if the bit is equal to 0, not equal to 1 in the sense the opposite thing says bit is equal to 0, then jump to the specified location. And next we can see JBC, jump target if the bit is equal to 1. First check the bit is equal to 1. After that clear that bit. Jump if bit, then clear. The meaning is this. So these instruction we should remember to operate with the bit addressable area. Let's have some example. Find out which by each of the following bits belongs. Give the address of the RAM byte in hexadecimal. So we have the set bit 42. So this is the address of 42. Then how we can set that bit? So this bit I need to 42 location I make to be 1. This is what I need to do. 67 bit I need to clear like that, so that we should remember the bit addressable area. So this is the area 42, it is comes to, this is the 42. This bit in the RAM I need to make it as a set, so that means I should make this to be 1. So that data bit, it is D2, in the location as 28 I made it as 1. So then other will be 0 0 0 0 0, this should be 1, this is 0 0. Now this address 28 holds the value as 0 0 0 and 0 1 0 0, that is 04H. Likewise I can make the bit as set or reset. Similarly we have the clear 67. So 67 is this bit, I can clear that, that means this should be 0, that is D7 should be 0, and clear F0F. So we have this is a 0F, that is we can make out to, sorry, this is a 0F, so I can clear that D7 bit. And set bit 28 bit of your RAM area, this is your 28 bit, that I can make it as to be set. And clear 12 bit, so D4 of RAM 21, so this is the 21, this is the D4 bit has to be, make it to be 0, this is supposed to be 0. And set bit 5, so this is your 5 location, this is the 5th location, so that I can make out to set that bit. Okay, so this is how we can understand the bit addressable programming concept. So this is the first module what we have discussed. Thank you very much.